Hello everyone. So today we're going to go over section 6.1, multiplying a fraction and a whole number. We will begin by multiplying a fraction and a whole number using pattern blocks. So if we are to model something like 4 times 1/3, then we will put in 4 groups of 1/3s, as we can see here. Group 1, 2, 3, and 4. And each one of these groups is actually representative of 1/3 of 1. Recall that the entire hexagon is 1, and each one of these parallelograms are 1/3. Notice that they can be rearranged so that all 4 thirds are on the right hand side. The first 3 1/3s make 1, and we are left with another 1/3. In other words, 4 times 1/3 is equal to 1 1/3. Okay. So look at a second example. This also works with improper fractions as well. So we are looking at 3 times 3 over 2, or 3 groups of 3 halves. So altogether, we have 3 groups of 3 halves that we can see here. This is the first group, 3 over 2, 3 over 2, and 3 over 2. So this is also, of course, 1 1/2. So here we have 1/2, 2 halves, 3 halves. In the next diagram, this is the 4th half, the 5th half, the 6th half, and then finally halves 7, 8, and 9. So altogether, we have 9 over 2, which of course is equal to 4 1/2. Another interpretation of this is we have 1 here, 2, 3, and here the halves number 3 and 6, they make up another 1, so this is the 4th one in this multiplication, and we're left with 1/2 here. So that's how we get 4 1/2, or 9 over 2, or 9 halves. So of course, the next question is, can we do this without pattern blocks for other fractions? And the answer is yes. So we're going to look at a couple of example as well, but without pattern blocks, with other models instead. So here we have 3 times 1 over 6. So very similar to the previous example. We have 1 over 6 here, the second 1 over 6, and the third 1 over 6. And they can be rearranged onto the same fraction strip. Notice that this fraction strip right here has 6 spaces in total. So it's meant to be equal to 1, or 6 over 6, if it's completely filled out. And we only filled out 1/6 of it. But if we have 3 of them, the rectangles can be rearranged so that here we have 3 over 6, which is equal to 1/2. So the whole point of this is 3 times 1 over 6 is equal to 3 over 6 is equal to 1 over 2. Okay. So let's look at one more. What if we have 3 times 5 over 6 instead? Well, so here, notice that we have the first group of 5 over 6 here. And a second group and a third group. only one of the spaces is unfilled or empty. So we have 1, 2, 3, 4, 5, and 6 of these 1 over 6s that can make 1. And then we have a second group of 1 over 6s, 1, 2, 3, 4, 5, and 6. So that will make 2. And we're left with, finally, these 3 here. Sorry, that's really hard to see. So what happens? Well, the first 6 of these 1 over 6s makes a 1. The second group also makes a 1. And so another way of writing this fraction will be 2 and 3 over 6. And that is the same as 2.5. So also then 3 times 5 over 6 is 2.5. Okay. So at this point, we might notice that there's a pattern emerging when we multiply whole numbers and fractions. So let's go back to the front here. In the first example, we can think of it as 4 times 1/3 is really just 4 times 1 all over 3, which is, of course, equal to 4 over 3. And as we saw, it is equal to 1 and 1/3. Likewise, in the second example, we have 3 times 3 over 2. So we can rewrite this as 3 times 3 all over 2. Which of course is 9 over 2, which is also known as 4.5. So if we are multiplying whole numbers and fractions together, we can multiply the whole number by the numerator of the fraction and then reduce afterwards. Okay. Here's same thing. Right, we have 3 times 1 all over 6. And that's how we get 3 over 6, or 1/2. And finally, with the last of the fraction strips example here, we have 3 times 5 all over 6. Which is equal to 15 over 6. And as a mixed number, this is 2 and 3 over 6, or just 2.5. Okay. Yet another representation of multiplying fractions and whole number. We can use a number line for it as well. Just going to do a quick example here. So let's say we start at 0. Notice that the fractions are in thirds. So every 3 spaces will mark it as 1. So each space will be then 1/3. So here's 0, and then 1/3 here. And then this will be 2/3, and so forth. So every 3 markers will mark 1. So this will be 2, 3, 4, 5, and 6. Okay, so we have 2/3 times 6. So we are actually going to have 6 groups of 2/3. So 2/3 will take us, the first 2/3 will take us to 0 to 2/3. It's just 2 steps out of 3. And the second one, 3, 4, 5, and 6. So what we have here is that 2/3 times 6 is equal to 4. Okay, so again, this can be thought of as 2/3 is the size of the steps, and the 6 is the number of steps. Oops. And also, if we are just going to multiply the numerator and the whole number together, then in this case we have 2 times 6, and it's going to be over 3. So here in this case, 2 times 6 is equal to 12, and so we have 12 divided by 3, or 12 over 3, which is, of course, 4. Okay, so it's just a different model to represent kind of the same thing. So next one we have 3 times 6 over 5. So in this case, we're just going to use the multiplication of 3 times 6. And then this will be over 5. So of course that means we have 18 over 5. And this can be written as a mixed number, 3 and 3 over 5. Okay. So kind of to summarize what we saw, multiplying a fraction and a whole number without using models or diagrams, there are going to be 3 steps. Step 1, we multiply the whole number and the numerator. Step 2, we reduce. And if necessary, in step 3, we can rewrite as a mixed number. So from here, just a few examples. So example 7a, we have 4 times 5, which is 20, all over 7. And this will be 2 and 6 over 7. Okay, likewise, next one, we have 1 times 12, which of course is just 12. And 12 over 3 is equal to 4. Next up here, oftentimes the word of likely means to multiply numbers together. So we have 7 over 3 times 9. So if we were to write that question out, like so. It's a neat trick we can use to reduce here. 9 and 3 have a common factor of 3, so we can simplify. We have 3 and 1. So the question then becomes just 7 times 3, which is 21. Very similar in the last example as well, the product of 5 over 9 and 18. So we can divide both those numbers by 9. We have 2 and 1 as a result. So the product here will be just 5 times 2, which is 10. Okay. Also, could have just multiplied the whole number and the numerator together. In this case, 5 times 18 is 90, and 90 over 9 is also just 10, so it works. Couple of quick word example here. A spider has 8 legs, and an ant has 3/4 as many legs. How many legs does it have? So here, 8 times 3 over 4. So if we multiply the whole number and the numerator together, we will have 24 over 4, which reduces to just 6. So that is 6 legs. Jenny is making a recipe that calls for 6 scoops of flour. She wants to make only 2/3 of the recipe. How many scoops will she use? So here we have 6 times 2 over 3. Okay, so if we are to multiply here, this will be 12 over 3, which is just 4 scoops. In this case, in both cases, actually, it is possible to reduce beforehand as well. Just to show it here, 8 and 4 are both divisible by 4, so we have 2 and 1, and of course 2 times 3 is 6. Likewise, in the second example, example number 9, 6 and 3 are both divisible by 3. That will leave us with 2 and 1, and 2 times 2 is also 4. Okay. So we looked at a few different models for multiplying a whole number and a fraction together, and then we were able to simplify the process to do so without the use of models or diagrams, and that's it for today. So thank you for listening.